We continue reviewing statistics. So in this problem, we have a local bakery that sells cheesecake, and the number of cheesecake sold in a day with the corresponding probability. And the question is, find the number of cheesecake that this local bakery expect to sell in a day. So this pretty much asks us to find the expected values or the mean. So for that, we have the values. This is x and the corresponding probability p of x. So we just multiply and then we add all of them up, or we just use a calculator using list on the calculator. So hit stat, and then enter. I'll just put x on list 1 and p of x on list 2. And then the corresponding probability on the second list. And then we just find two variable statistic, one variable statistic, list 1, and frequency list will be list 2. And then we'll calculate. Right, the mean is 14.1. Once again, this will go to list 1, this will go to list 2, and to get this, it is one variable statistic. If we do it by hand, we multiply those numbers and then add them up. So we can do this. On list 3, I multiply list 1 times list 2. And we just add all of this up. Of course, we should get the same thing. Right. The next one, 1,000 tickets are sold at $2 each. One ticket will be randomly selected, and the winner will receive a color TV of the values of $387. What is expected value? So this is pretty much the same type of problem. So in this case, I will construct a table. Like this. First there's outcome, and then the value and probability. So the outcome is there's one winning ticket. So either we win, when winning though, the values of plus 387. But regardless, we still have to pay $2 for the ticket. So the actual values is 385. Of course, if we not win, we lose. We only lose $2 of the ticket. Now, 1,000 ticket. are shown and one winning ticket out of 1,000. 1 divided by 1,000. And the not winning will be the complement of this. So it's 1 minus that. So there's 999 ticket that is not winning. So 0.99 and 9. Right. Now, if we want to do this by hand, just multiply straight across and add. So I just said 385 times 0.001 plus -2 times 0.999, and we have negative 1.16, and this is in terms of dollars. So we say expected values. First multiply straight across and then add. So expected value or the mean is equal 1.61. This is money, so we round to the pennies. 1.61, and it has the negative. So negative meaning, of course, we're losing money, and that's what it should be. Right. Of course, if it's simple like this, we don't need to use the list. Of course, you can put values in list 1, probability in list 2, and then do one variable statistic. We should get the same thing. Right, next. In a pizza takeout restaurant, the following probability distribution was obtained. So X represents the number of toppings, and with the corresponding probability, find the mean and standard deviation. So on this one, I definitely recommend that we use the calculator to find the mean and standard deviation. For a probability distribution. Right, so it's that. So first we clear, then enter, clear, and then enter. Don't hit delete. Highlight, clear, and enter. Right. Now enter X. And then L2. Right, and then stat. Calculate one variable statistic. The list, the values, list 1, the frequency list is list 2, which is the probability, and then we just calculate. Right, so we have the mean, we just have 1.14, even though they used for the sample, but I think this we can just use that for the population. Standard deviation, sigma is 1.04. Right. Yeah. Like I said, if we have the list and probability distribution, that we ask for the mean and standard deviation, I'll just go ahead and use the calculator. Right. Next we have different things. Assume that male and female births are equally likely, and that the birth of any child does not affect the probability of the gender of the next one. Find the probability that of exactly 3 girls out of 10 births. So we have exactly 3 in 10 births. And so this is a classic example of binomial probability. So binomial, that means there are 2 outcomes. In this case, a male and female, and equally likely. So we have 50% on each. And so we have the fixed number of trial, 10 births. So let's list what we have. So fixed number of trial. Right, equally likely, and so that means 50 and 50, 50% on each case. The important thing here is we have that the birth of any child does not affect the gender of another one. So we have fixed number, fixed probability of success. When we talk about success here, we do not mean that it is a success or failure. It is success is the case of that we're interested in. So this case, let's say we interested in the case of female births. So in that case, the probability of getting a female is 0.5 or 50%. And so that is considered success or failure. Like I said, it's not success or failure here. It's just success is the case, the outcome that we are interested in. In this case, since we want the girls, so that will be considered to be success. And then next, we want to find the probability that exactly 3 girls. So the question is, find the probability that X is exactly 3 girls. So this is just a binomial distribution. So second variable, go to binomial PDF and CDF. The difference between these two, for P, if we just want one particular case, if we want binomial CDF, that is cumulative from 0 to that number. So since we only have one values, this is binomial PDF. Highlight that this is going to be P. We have 10 trials, probability of success, and we want exactly 3. So and we have 0.117. Right, to test that. Right, next. A quiz consists of 10 multiple choice questions, each with 5 possible answers. 1 is correct. To pass the quiz, the student must get 60% or better on the quiz. If a student randomly guesses, what is the probability that the student will pass the quiz? Right, so we have 10 multiple choice questions. So that is the fixed number of trial. Yeah. So for the binomial probability, we have to have those properties: fixed number of trials and fixed probability, and only 2 outcomes. So fixed number of trial have n equal to 10, each with 5 possible answers and 1 is correct. So 1 is correct out of 5. So that is fixed probability of success. Now, success in this case is guess the right answer 1 out of 5. And to pass the quiz, student must get 60% or better. So in that case, what is the probability that the student will pass the quiz? So we pass the quiz, the student have to get 60% or better, meaning that have to get 6 questions right or more. So that's what we have. Right, so unlike the last problem where we have x equal or exactly equal to, this is greater than or equal to. So where we have greater than or equal to or less than or equal to, we should use binomial CDF. The only problem here is if we go with the binomial CDF, so first 10 and 2.2. Now the x values here, the binomial CDF, it only goes from 0 to that number. This is from 6 to 10, so that's not it. So for this we have to write the complement. If it's not greater than or equal to, it has to be less than 6. Now that's, we still cannot use that. If we want to use the calculator, we have to write that as less than or equal to. This is the binomial CDF, work when it's less than or equal to. So in this particular case, it's less than or equal to, and it's discrete. So we just have 1, 2, 3, 4, 5, 6. If it's less than 6, it has to be less than or equal to 5. So we just have 1 minus binomial CDF. I highlight this, it's going to be C, 10, 0.2, and 5. We have that. I will take 1 minus that. I have 0.0062. So the chance to pass by guessing here is 0.64%. So of course it's really small. Right, so I have that one. Right, same thing here. Assume that the male and female bird out, so this kind of like what we have earlier. Find the probability that at most 3 boys in 10 birds. So once again, we have 10 trial, and this is at most 3. Right. So we still have fixed number of trial. And the fixed probability of success. In this case, success is having some certain characteristic. In this case, is having a boy. And is equally likely and also independent, meaning that any child does not affect the probability of getting another child. Right. And in this case we want at most 3, meaning that could be 3 or less. Right, so this is less than or equal to, so we just go ahead and use binomial CDF. If it's greater than or equal to, we need to convert it, but if less than or equal to, we don't have to. Right, and we have 0.172. Right. So once again, binomial CDF is a probability distribution from 0, 1, 2, all the way to whatever that number is. So it's less than or equal to. If it's greater than or equal to, we need to convert this back. Right. Next, a test consists of 100 multiple choice questions. So that's a fixed number of trial, each with 5 possible and only 1 correct. 1 correct, 5 possible answers. Find the mean and the standard deviation of the number of correct answers. Right, so again, we have fixed number of trial, this case 100, and the probability of guessing the right answer is 1 out of 5, which is 0.2. This problem asks for the mean and the standard deviation. So the mean is just NP. So we take 100 times 0.2, of course that is 20. So that makes sense. If we have 100 questions and the probability to get the correct answer by guessing is 1 out of 5, which is 20%. So 20% of 100 is 20 questions. So if we guess the whole test, most likely we'll get around 20 questions, which makes perfect sense here. Right, so that is the mean. Standard deviation. It's the square root of n times p times 1 minus p. So we have square root of 100 times 0.2 times 1 minus 0.2, which is 0.8. Right, so we have exactly 4. So the mean is 20, standard deviation is 4. So yeah, so for binomial probability, the mean is that and standard deviation is that. Right, next. The probability that an individual is left-handed is 0.16. In the class of 10 students, what is the mean and the standard deviation of the number of left-handed students in that class? So we use the same thing here, the mean and standard deviation. So that 10 students, that is n, and this is probability. So that's 1.6, and the standard deviation. So very straightforward. .159, so let's 1.16. Alright, so once again, the same thing as the previous question. Right, now we go to different things. Set the length of time that takes car student to find a parking spot in the library is normally distributed, so we set normal distribution. We have the mean, standard deviation. Find the probability that a random selected car student will take between 2 and 4.5 minutes to find parking spot in the library. Right, so first, let's summarize. We have normal distribution. And in this case, the mean and the standard deviation. Right, so we need that, so we just draw the bell curve. Not bell curve, just the normal curve. Just try to draw as symmetry as possible. Right, so we know it is in the middle, it's 3.5. And we want the probability, so the probability is the same as the area, is the same as the proportion of the population. So it is from 2 to 4.5, so 4.5, let's say about there. And then 2. So we ask to find the probability that it will be between 2 and 4.5. So pretty much we'll find the area like that. So it will be under second variable, normal CDF. So to find the area under the normal curve, we use the normal CDF. Right. We have from the low values of 2 to 4.5 standard deviation. The mean is 3.5, standard deviation is 1. And we compute, so write out. We go from 2 to 4.5, the mean and standard deviation. So do that. Have 0.7745. Right, so very straightforward. So usually this type problem, we will see the question say that it is normally distributed and the mean and standard deviation. So we come directly from that. Right, next one. Suppose a brewery has a filling machine that fills a 12-ounce bottle of beer. It's known that the amount of beer poured by this machine, once again, normally distributed. We have the mean and standard deviation. Find the probability that it is fewer than 12.09 ounces of beer. So let's write out the summary. We have normal distribution. The mean of 12.19 and standard deviation of 0.04. Right, so we know it is normal distribution, so we can draw a curve, normal curve. Of course, try to draw as symmetry as possible. I didn't do a very good job there. Anyway, we know the mean is 12.19, so be right in the middle. And this is fewer than 0.09, 12.09. And it's fewer than that. So we will talk about this area there. So if we want the area, it is just normal CDF. Right, so in this case, we go up to that number. Usually we choose the number very small to that. Could be negative 999999, or could be 0. Of course, it's not unrealistic that the filling machine that could fill a negative number. But like I said, if we put negative 9999, that still makes perfect sense. We'll just essentially put 0 in there, is fine too. So any small number that significantly further away from the mean, yeah, almost too far away from the mean compared to that number, is fine. So I think we put 0 there will be perfectly okay there. Of course, we could put a negative number as well. Go up to 12.09. The mean, standard deviation. Right, let's say if I put that number, right, yeah, 0. Right, what if we put, instead of negative 100, we put 0. We have 0. So the probability is extremely small. Oh, it's not 12.19, sorry. Right, like that. Right, like I said, if I put 100, negative 100, yeah, the number should not change. Like I said, whatever the number we choose have to be on the tails, have to be significantly further away from the mean than that number. In this case, we choose 0, which makes sense. But essentially, we cannot have anything lower than 0. Realistically. Right, so we have that. Next, a firm believes the internal rate of return for its proposal investment can be described by a normal distribution with the mean and standard deviation. So even though it's given in percent, but that is fine for the probability that the internal rate of return for the investment exceeds 50%. So pretty much like what we have been doing. Normal distribution, mean, standard deviation. So the mean and standard deviation will be 0.03. So we can draw the normal curve. Right. And the mean is 44%. This time we want exceeds 50%. So be more than that. So if we want to write that is when x is more than 0.5. So this is normal CDF. We go from 0.5 to a very big number. Now the very big number could be 1,000, but in this scenario, realistically we cannot get more than 100%, right? So as I said, you can put 1 for 100%, or I said 10 or 100, it doesn't really matter. The calculation will not change by that. Right. So lower bound, upper bound, mean standard deviation. Right, let's try that. Second variable, normal CDF, 0.5, 10, 0.44, 0.03. Right, and calculate that. Have 0.2275. Right, so we have that one. Right, next, for standard normal curve. So the difference between a regular normal curve and the standard one we talk about the z-values. For the z-score, that separate the bottom 90% and the top 10%. So this is the normal curve, standard normal curve. So standard normal curve, the difference is the standard normal curve, the mean is equal to 0, standard deviation is 1. So that is the standard normal curve. And we want the break that we set the bottom 90% and the top 10%. So we also find these z-values. Right, one thing to note, in this case, if we use the calculator, we're going to go with the inverse normal. So normal CDF to find the area. Inverse normal is when we're trying to find the values when we know the area. We know the area is 90% on the left. And 10% on the right. 0.1. So remember, if we want to find the values, it is going to be inverse normal. So enter something of 0, standard deviation is 1. So we have that part. But whatever we enter here, it has to be the left area. So the area on the left of Z. So in this case, that is 90%. On the left. And 1.28. Right, so that's what we have. Right. Next, we have a new phone system. So last year to help all of that. Now the important things here, of course, normal distribution, the mean, and standard deviation. Find the point in the distribution below which 2.5% of PCE personal core span fell. So we want below the 2.5%, so the very small. Right, again, write down the details. This is normal distribution. The mean of 500, standard deviation of 50. So we can draw the normal curve. Uh, 500 in the middle. And this time we want below 2.5%. So this is only one the bottom, 2.5%. We asked to find the values. Once again, this is inverse normal if we want to find the values. And in this case, it's not going to be Z because it is not standard normal. So we're just going to have X. Z is when the mean is equal to 0 and standard deviation is 1. So just inverse normal. Right. We're going to enter the area on the left. The mean is 500. Standard deviation is 50. So we just have that. And we want just the area on the left is 0.025. Right, obviously that's not right because the mean is 500 and the standard deviation is 50. Sorry. Actually, 40.2. Right. Yeah, because that's in terms of money, so we have 2 decimal places. Right, that's what we have. Right, next, the length of time it takes for a student to find parking spot. Okay, all the good stuff is here, the normal distribution, mean, and standard deviation. Find the cutoff at which 75.8 of current student exist when trying to find the parking spot. So Usually when the problem involving time, have to think a little bit carefully, because in terms of time, faster will be smaller. Usually it's better, so be careful with that every time we deal with time. So normal distribution, the mean 6.5, standard deviation is 1. So we draw the normal curve. And the mean is 6.5 in the middle. Right, now have to be careful. I'll find a cutoff time with 75.8 of the college student who exceed. So let me ask you that. Is that going to be more than 6.5 or less than 6.5? Think about this. 6.5. If it is more than 6.5, then that would be worse. And we want 75.8 of the student exceeds will be, so 75.8 of student will be more than that. So in that case, we have to set up in this area. With 75 college student exceeds. Right. So, of course, if we look at all of that number, that's all of them on the right side, so we know it's going to be on the right side. But we know it's going to be 75.8%. Right. So that's not very clear, but the cutoff time which 75.8 of college student exceed. So 75.8 of student will have to be exceed in that time. Anyway, so just inverse normal. Uh, 0.758 mean standard deviation. Oops, I don't need to go that far. Right, about 7.2. Right, so that was that. Right, now we go to different things. So in this case, what we have earlier is normal distribution. This is still normal distribution as well, but will be two scenarios. Number one, the population is normal distribution, then the sample will also be normal distribution. Number two, if the sample size is big enough, then the population doesn't have to be normally distributed. But in general, for the population, I'll write this down here. For the population, we have the mean and standard deviation, and then for the sample mean, so the mean of the sample, the average of the sample, we have the mean of the sample, the mean of the sample mean is equal to the same thing as the population, and the standard deviation of the mean is equal to standard deviation of the population divided by square root of n. So that's what we have. So the mean of the sample mean is the same thing as population mean and standard deviation of the sample mean is standard deviation divided by square root of the sample size. So we have 11 divided by square root of 19. Is 2.524. Right. Right, next, assume that blood pressure readings are normally distributed. So, normally distributed, mean of 117, standard deviation of 8. If 100 are selected, so this is for the sample, that for the population. Now the sample of 100, find the probability that will be less than 119. So this is the sample mean less than 119. Alright, so let's write out what we have. The population is normally distributed. With the mean of 117 and standard deviation of 8. So that's for the population. Now go on to the sample. Sample mean. The mean of the sample will be the same as the mean of the sample mean is same as the mean of the population. And the standard deviation of the mean is standard deviation of the population divided by square root of n. So we have 8 divided by square root of for the sample mean n is equal to 100. So 8 divided by 10, 0.8. And we want the probability that will be less than 119. So find where the mean is less than 119. Right. So it's still normal distributed. So we draw the normal curve. Right, and the mean is 117. Yeah, 117. And this one we want less than 119. Right, so, and to calculate the area, this is going to be normal CDF. And we'll go from very small number. Of course, small number, you could use some negative number or just use 0 because the reading cannot go any lower than 0. Again, we choose a number that is significantly smaller than this relatively to the mean. So we have to choose very far enough. So 100 is not far enough. 0 could be far enough. Any negative number also fine. So we go from 0 to 119. The standard deviation is 117. But notice that we have to use the standard deviation of the sample mean. So pretty much that. Zero, 119, 117 and 0.8. Now we have 0.9938. Right. Right, next, the average score of all golfers for a particular course has the mean of 80 and standard deviation of 4.5. Suppose 81 golfers played the course today. Find the probability that the average score of 81 will be more than 81. Alright, so population. In this case, we don't know if the population is normally distributed or not, because it did not say, so unknown distribution. We do know the mean, and standard deviation. Now onto the sample mean. We have n, there's 81 of them. The mean of the sample mean will be the same as the mean of the population. And standard deviation of the sample mean is standard deviation divided by square root of n. So 4.5 divided by square root of 81. Square root of 81 is 9. 4.5 and 9 is 0.5. Right. Now, this problem, even though we don't have the normally distributed population, we still can use that because n is big enough. If it is greater than or equal to 30, central limit theorem applies, and it will be approximately normal. Yeah, n is big enough. It means 80. Now we want more than 81. So area will be normal CDF. The lower will be 81. And the big number will be something that is significantly bigger than these two. So 90 to 1000. I said it doesn't hurt to go that far. The mean is 80. Standard deviation, use this one, not that. Use the one for the sample mean. Right? $81 to 1000 or 10,000 doesn't matter. It's sure it's big enough. Right? We have 0. Whatever that is, 0.02275. Right, next. The amount of money collected by a snack bar at a large university record daily in the past 5 years. The record indicate that the mean daily collect was okay. And now to set. The distribution is skewed to the right due to several high volume days. For example, that. So obviously this is not normally distributed. But should it be matter? Answer is No, because we do have big enough sample size. If it is greater than or equal to 30, that should be fine. So the mean of that and standard deviation of that. And then the question is, suppose 100 was random, and the average was to call which of the following describe the sampling distribution of sample mean. What is, I think, the typo that should give us something here. So yeah, we just skip this one then. But, yeah, which of the following we don't have anything there. Right, just go to the next one. Right, the U.S. housing market estimate 31 of home purchased in 2019 will consider investment properties if the sample of 800. So usually this type of problem, there is an assumption that we need to check, but in terms of math on the test, you don't have to check the assumption, just go straight ahead with the calculation. Usually the sample have to be small enough for the population, like it's less than 5% of the population, and n times p times 1 minus p have to be greater than or equal to 10. I said in math, when we do the test, you don't have to check that, because if the assumption has to be made in order for us to do the calculation. Right, so we have the sample of 800 homes, and we want at most 250 homes are going to be used as investment properties. Right, so what do we have here? So we have the probability that 31 of is for the population. And then for the sample 800, the proportion of that is roughly 31% as well, and standard deviation of that is square root of p times 1 minus p over n. So we just do that. Divided by n. So we have that 0.01635. Right, and so this also followed. Of course, if we check all the assumption, it will pass, and this will be approximately normal. Without it, we won't be able to calculate. Right, so what is the mean here? Actually, it's going to be 31 and then the question find the probability that it is at most 250. So we say probability that x will be at most meaning equal to that or less. Or if we divide by n on both sides, divide by n, in this case 800, 250 divided by 800. Right, so a little bit on this right side here. And at most, so be equal or less. So that is also normal CDF. That goes from very small number relatively to this two. You could choose negative 100, but like I said, 0 could be enough because significantly smaller than this two. Right, you have 0.5608. Right. Next, Smith is a well inspector at the shipyard. To keep track of good and substandard. That 5% of all wells done will be substandard. So the population will be 5%. I mean, for the population, the proportion is 5%. If he checked 300 out of 7,500, so 7,500 the population, 300 is less than 5% of the population, so that's what's good. And we can check that n times p times 1 minus p is greater than or equal to 10, so that allows the this to be approximately normal. So sample of 300. So we can estimate that is the same thing as the population and standard deviation. Right. Zero 0.012583. Right, so also normal distribution. Right, now we want it between 10 and 20 substandard. So probability of x between 10 and 20 Now if we divide by n everywhere, n being 300, so we will have probability of 10 divided by 300 between that. And then 20, of course, going to be twice that number. Right. So that's just normal CDF. Between these two numbers, the mean standard deviation. Right, so about right. Let's do this math again. Oh, I forgot a zero. Yep, that makes a lot more sense. So make sure you enter the number correctly. Right. Next, when 425 junior college students were surveyed, 117 say that they have previously owned a motorcycle. Find the point estimate for the population. So the point estimate for the population proportion, which is the p hat. So if we want to estimate the population proportion, the best way to go with is just what we have from the sample. From the sample we have it's going to be x divided by n. We're going to have 117 say yes out of 425. So the point estimate is whatever the sample is. We assume the population will be the same as that. So that's called the point estimate based on the sample. Be exactly the same as the sample. Be just that. Right. Next. A survey of 300 non-fatal accidents showed that 108 involved in uninsured drivers. Construct a 90% confidence interval for the proportion of fatal accidents that involve uninsured drivers. Right, so what do we have here? 300 and then we have 108. So we have n of 300 x of 108. And of course we can construct 90% confidence with all the formulas and other things, but in the calculator the second variable, sorry, this is very stat and then go to test, and this is have to look for the interval, and so one proportion z interval. So one proportion z interval with those three information. X is 108, N is 300, and 99% confident, or you should say 99% confident. Then calculate. We have between 0.28862 and 0.43138. Right, so simple enough. Next, it is thought that not as many Americans buy presents to celebrate Valentine. Right, so the sample 4,000, and then 200 who bought their significant other present, right? And then we want 90% confident interval. So pretty much n, x, and then 90% confident. Once again, one variable statistic. So it's that. So there's 2,200 out of 4,000. Oops. And we construct 90% confident interval. And that's what we get. So this is one prof. Z interval with x is 2,200 and is 4,000, and the confident interval of 90% confident interval. Right. Next, a senator wishes to estimate the proportion of United States voters who favor new road construction. The sample size should be obtained in order 90% of confident interval that the sample proportion will not differ from the true proportion by more than 4%. Right. So in this case, what we have is 90% confident and not differ more than 4%. So this is error is 4%. And what sample size needed to have that? The question asks for what sample size. So when we ask for the sample size, there are two types of problem. One is we know the previous proportion. In this case, we do not know. If previous P is unknown, the sample size is equal to 0.25 Z over E squared. Right. So the 90% confident, we do need to find that though. So if we want 90% confident in the middle, we just need to find Z values here. So if 90% in the middle, 10% on the two sides, on the two tails. So meaning that this will be 5% here. So if you want to find the Z values corresponding to this, which we put here, it is inverse normal of 95% on the area on the left of that point. 90 in the middle, 5% on the left. 95% on the left of that point. And then this is z, so mean is 0, standard deviation is 1. So at 1.645. Right. We can put in here for z over the margin of error of 4%. Right. So that's what we have, and we always round up for this scenario. Right, so that is where the p is unknown. If previous p is known, then they're going to be different. So the next problem, we have still no more than 4%, so this a is 4%. Previous indicate that proportion. So with previously we now have p is 11%, which is 0.11, and we have 98% confident. So we have to base on this and to find the z. So we have 98% in the middle. That means 2% on the two tails. So one tails has to be 1%. So if we want to find this z values, it's going to be inverse normal. All the area on the left, 98% plus 1% is 99%. Have 2.326. Right, and the sample size will be equal to p hat 1 minus p hat, and then the same thing is this, z alpha over 2 over e squared. Right, so put all the numbers we have, p hat 1 minus p hat, z over e squared. We have 331. Of course, if we take a few more digits, if we want to have more accurate, it's fine. So I will stack a few more. Right, so we have that. It's about 332. Alright, I'll stop the video here and then we pick it up on another video. Thank you for watching.